Oh, students, right back again. Today you have practice problems 10.4.3. As always, you should be trying these problems before you check them here. And you can do them one at a time, or you can do them all one time. Come back and check them all. Today we're going to be doing some work with molecular formulas. Number 30. We have given a percent composition, so first thing we got to do is figure out an empirical formula, as we did on the last group of problems. So we've got 58.54% carbon, so we'll switch that to grams of carbon. Then we'll be changing that into moles. We got 4.91% hydrogen. Change that to grams, and we'll be switching it to moles. And 17.06 grams of nitrogen. And 19.49 grams of oxygen, which we'll be switching to moles. Then we go to our periodic table, and we know that 1 mole of carbon is 12.011 grams. 1 grams of carbon. Maybe by now you have that one memorized. 1 mole of hydrogen is 1.0079 grams of hydrogen. There's another one you might have memorized by now. Nitrogen we use quite a bit too. Maybe you can remember this one. 1 mole nitrogen is 14.007 grams of nitrogen. And oxygen, one we've used over and over. I'll definitely know this one. 1 mole of oxygen, 15.999 grams of oxygen. And we'll go through and do all of our division. And we get 4.874 moles of carbon, 4.872 moles hydrogen, 1.218 moles nitrogen, and 1.218 moles of oxygen. And as we did earlier, we divide them all by the smallest one, which is the 1.218. 1.218. 0.218. 1.218. And that results us with a... I'm going to switch colors here and just write over the top of it so it makes it easier to see. So I'll switch colors. So we got 4, 1, and 1. So that makes the empirical formula. Become C4, H4, NO. Then you have to go back and find the molar mass of that C4H4NO, and that would just be taking the 4 times 58, 4 times 4.91, 1 times that, 1 times that. Oops. Back up, back up, back up. I went to the wrong place. That's 4 times that, 4 times that, 1 times that, 1 times that. So I got them all written down up there. And then multiply, 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 and add all that up, and we find that is 82.08 grams per mole. And then up in our problem, it told us we had a molar mass of 164.16. So, right over top here, 164.16 grams per mole divided by 82.08 grams per mole. I'm not going to write them down because they're just going to cancel out anyway. We divide that, we get a 2. So then we got to come back down here and we take our empirical formula, and I think I'll switch colors one more time. Go to green. And we take our empirical formula of C4H4NO, and we're going to multiply that by 2, resulting in nice orange color for our answer, resulting in C8H8N2O2 is our molecular formula. Number 31. Basically the same type of problem. This time we have 40.29% boron, so again we switch that to grams, and we'll be changing that to moles. We've got 7.51 grams of hydrogen. We switch that to moles, and 52.20 grams of nitrogen, and we're going to switch that to moles. So 1 mole of boron is 10.81 grams of boron. Grams divide out grams. 1 mole of hydrogen is 1.0079 grams of hydrogen. Grams divide up grams. And nitrogen, 1 mole of nitrogen is 14.007 grams of nitrogen. Grams divide out grams. We'll go back and do our division for each one. And we find that we get 3.727 moles of boron. 7.451 moles of hydrogen, and 3.727 moles of nitrogen. And as we've been doing, we'll go back and divide by the smallest one, 3.727, 3.727, 3.727. And that leaves us, after we divide those, leaves us with a 1 and a 2 and a 1. Meaning our empirical formula then is B2H2 N. And I have to go find our molar mass for that, and like we did in the preceding one, we got all our information we need for that. We just need to multiply, 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 and then we're going to add those up, and we get a molar mass of 26.83. That would be again in grams per mole. And we go back and they gave us a molar mass of 80.50, so we'll put that on top. 80.50. We divide those two things. Looks like it might be time for a new color. And let's go to orange. And we divide those two things and we get a 3. Then we just take our B2H2N and we take it times to 3, resulting in our molecular formula of B3. That's not a B2. That's supposed to be a B1. Heck, no 1 there. No 2 there. B2, B1, H2N. So that gives us a B3, an H6, and an N3. So, really easy to write something down sometime, make mistakes. If you make mistakes, you just got to go back and fix it. And understand what you did wrong. And we got another one, same basic type of problem. So we've got 71.02 grams of silver. We'll be switching that to moles. We got 7.91 grams of carbon. We'll be switching that to moles. And we've got 21.07 grams of oxygen, which we'll be switching to moles. So, silver, one we haven't done much with. 1 mole of silver, 107.87 grams of silver. Grams divide up grams. Carbon, again, one you ought to know by now. 12.011 grams of carbon in a mole. Grams divide out to grams. Oxygen, another one, just ought to know. 15.999 grams of oxygen. If you remember these, it just saves you having to go look them up on the periodic table. So I do all the division again, and we get a 0.6584 up here. I'm going to leave off all the units this time. 0.6586. And a 1.317, and we're going to go back and divide by the 0.6584, 0.6584, 0.6584, leaving us with a 1, and a 2, meaning our empirical formula then has to be, and we'd write the Ag first, Ag CO2. And again with a little multiply and multiply, multiply and add, we can find its molar mass of that empirical formula gives us 151.879. And we were told we had 303.8. We divide those two things and get a 2. So that means we need to take our empirical formula times 2, and we get an Ag2C2O4 for our molecular formula. Nothing new on this later, same problem, different numbers, different compounds. So number 33, we have 27.87 grams of phosphorus will be changing. And just a couple elements this time, 72.13 grams of sulfur. So our molar masses is 1 mole of phosphorus is 30.974 grams of phosphorus, and 1 mole of sulfur is 32.06 grams of sulfur. There's another one we've used a lot of. Good one to remember. You know, some of them, like phosphorus, if you can remember, it's around 30, 31. You'd be in pretty good shape. Now do our divisions, and we get a 0.8998 and a 2.250, and we divide by the 0.8998, divide by the 0.898, switch colors so we can see what I'm doing. We'll go to blue, and we get a 1 and a 2.5. Now, we got the fraction in there, decimal. We gotta get rid of it, so we'll multiply them both by 2. And that leaves us then with a 2 and a 5. 2 and a 5. So, meaning our empirical formula then is P2S5. And we go through and calculate our molar mass, so we multiply, and add those together, just finding the molar mass. Again, everything's written down here. Don't have to go looking it up again. And when we get that all calculated out, we find it has a molar mass of 222.3 grams per mole, which is same as what we had up here, which tells us the empirical formula and molecular formula are the same thing. So, same. So that's our answer. Number 34. Okay, we got some carbon. 52.93 grams of carbon. We'll be changing that. 5.92 grams of hydrogen. 41.15 grams of nitrogen. So again, just figuring out our empirical formula first. Carbon, 1 mole. Carbon, 12.011 grams of carbon. Hydrogen, 1 mole of hydrogen is 1.0079 grams of hydrogen. And as always, if you're using a different periodic table and they have a few more, a few less decimal places on mole mass, it doesn't make any difference. As long as we have more on our molar mass of the elements than we do on our what we're working with, given. So make sure you have enough sig figs. And 1 mole of nitrogen is 14.007 grams of nitrogen. Then we go through and do over divisions here, and we get 4.407, 5.874, and 2.938. You can divide them all by the smallest one, which is the 2.938. 2.938, 938, and after we get all of our division done, we get a 1.5, a 2, and a 1. Got to get rid of the decimal. The 0.5 is multiplied by 2, so we take them all by 2. That gives us a 3, a 4, and a 2. Meaning our empirical formula then must be C3, H4, and 2. Yeah, we go back and find our molar mass of the empirical formula. So again, we'll match all those up, multiply and divide, and that gives, or multiply and add, that gives us 68.08. And we were told of the empirical, or the molecular formula, it was 204.2. We divide those and get a 3. So we'll come back down here, we got to take this thing times 3, C9, H12, N6. So that's our figuring out molecular formulas. Well, that's all for now. Next time we'll be doing some practice problems on Next practice problems will be for section 10.5, where we'll be looking a little at some stuff we call hydrates. So that's all for now.